Hello everybody, this is Carol speaking. Welcome to our PolyWorks webinar. Today we're going to talk about how to optimize polygonal models for inspection and downstream applications. Let's welcome Todd Anderson as he is our presenter today. Todd is a member of the technical support group. And let me remind you that if you have any questions, please use the questions panel. I will be monitoring the questions throughout the webinar. We will have a short Q&A session at the end. If we don't have time to answer all of the questions, we will get back to you by email. And yes, this webinar is being recorded, so it will be available for later viewing. So Todd, it's all yours.
Great, thanks, Carol. So with the release of PolyWorks 2019 back in April, Inspector Premium customers have available to them now the module Modeler Lite. This module has many advantages for Inspector Premium customers to improve their polygonal models for aesthetics purposes, as well as maybe to reduce the overall size of large number of triangles and models, especially like when customers that are using CT scanners. So what I'd like to do is go through the process, or a typical process, of where a customer could use Modeler Lite and help them out with their Inspector Premium process. So starting off, when we're in Inspector Premium, you guys may remember from a previous video that to transfer a polygonal model from Inspector to Modeler, it's as easy as just a simple right click and go transfer to PolyWorks Modeler. Now, the premium customers, what will happen with this is it will automatically open up into Modeler Lite. And for those customers that have a full license of Modeler, you'll notice that there are a lot less icons on the screen. Modeler Lite is a streamed down version of the full Modeler package. So here's a typical scan of a model that has been done. And we can see on this model that after it's been imported in within the scan, we have some holes in the model, as well as this part is a little bit rough. So one of the tools that we can go through, and one of the things I always teach when I'm going through Modeler, is we can use a workflow of left to right across the top of the screen. And one of the first icons we can use is smooth vertices. So if you have a model that's kind of rough, when we look at this, maybe for screenshots or when we're presenting this, we would like to have a smoother surface, we can actually run the smooth command. It gives us the ability to go through and paint, much like what we were doing in Inspector, where we would select using element selection. You can kind of see that we have that same paintbrush here, and we can simply go through over top of the surface, and it kind of paints down, or it's almost like it's sandpaper, and we're smoothing the model down. How aggressive do we smooth can be controlled by a slider here, where I would like to have this smooth a little bit more aggressive, and we can see that that can be done. Now, the first thing everybody thinks is, okay, I'm distorting the model. Well, remember, I'm showing this to be aesthetic as far as making changes. However, we can also go through and we can set how much displacement we would want. So for us going through and smoothing, maybe what I would like to do is smooth the model, but I don't want it to change more than, say, 50 microns from its original position. So that would give us some control to go through and change the appearance of the model without changing, say, measurement or values of the model greatly. Now, we also have the ability to go through and smooth the whole model itself by just simply selecting smooth itself, and the algorithm will run in the background, and it will take into consideration areas that have higher curvature, the areas that are fillets. It'll do a little smoothing there, as well as smoothing the entire overall. It takes a few seconds for it to work. However, the results are you would have an overall smooth model, and if we had displacement set for this as a baseline, we could actually improve the aesthetics of the model without, say, distorting the model or taking it away from something that we would want to measure. So that takes a little bit longer in a webinar. However, it does a really good job of smoothing. Now, the next thing available for us is we have what we call the Reconstruct Mesh icon. So that's this one up here that has the stars with the hammer. When I'm teaching this, I call this the magic hammer. And the reason I call it this is when we go through, one of the things that we would do is we can pre-select an area, say this date stamp that's in this casting here. As this goes through, I would like to get rid of that. So I could either delete it and fill the holes in. However, this command will do all of that for me by simply clicking on that. All I need to do is highlight that area, and you can see it's gone and everything's nice and smooth. So we have the ability to get rid of what I would call anomalies. There may be spikes in the data. There could be a casting that has some parting lines that are still there, dust, stickers, things along those lines. We have the ability to get rid of those very quickly by just painting them and clicking that button. Now, the next tools that are available for us would be hole filling. We have one that's an automatic hole filling, and we have an interactive hole filling. I want to skip the automatic one, and I'm just going to go to the manual one first, but let me rotate them all around and let you guys see where we have some holes in here. So this is a typical scenario where we've gone through and scanned a part, and let's say that the part is no longer available for us to go back and rescan the areas that we missed, or someone else is using the digitizing devices. So in this instance, we can actually use the hole filling command to go in and fill these holes in. Now, in the interactive mode, you have a lot of methods inside that you can use. And what happens when we go into this hole filling mode is it puts us into a mode that identifies all the holes, and you can see them, they're highlighted in orange. And for us to fill the hole in, all you have to do is go pretty close to that hole. It'll highlight, and you simply click, and the hole fills in automatically for us. Now, with the interactive, you have the ability to go through and use other methods. So maybe I want to only fill the hole in a little bit at a time. Well, within the interactive mode, what I could do is I could pick this hole right here, and then I have the ability to fill in one side or the other just by simply highlighting and clicking, and the software will go through and take care of that for you. So you have the ability to manually go through and fill in holes. However, one of the nice things is that you have an automatic hole function. Now, when I launch this, it will go through and identify all the holes that are in the polygonal model. And then if I have openings that are in the model that are features, I can come through and set a parameter that says anything that's larger than, say, 20 millimeters in gap, that's going to be a feature hole, and that's not really a hole I want you to fill in. I want you to disregard that. But the algorithm works very well for hole filling and automatic hole filling. There was probably a couple hundred little tiny holes all over the place that would take me a long time to go through and click on the model. However, if I run the automatic hole filling, it's done within 5 to 10 seconds. And my model now has no holes in it. So these tools that we're using is giving us this advantage to improve this polygonal model for screenshots and other processes down the road. Now, one issue is that may occur is sometimes when we're working with polygonal models, or let's say we're in Inspect and we have a polygonal model, everything looks okay, and we go to do a surface profile, but within the surface profile, all of a sudden we have this spike. Well, sometimes those spikes are a result of data that is floating in layers. So even though I've gone through and filled in holes, another command in here can be what we call analyze boundaries. Right now, I only see the polygonal model. If I run this command, what this will do is it will identify if you have anything that has what is called an open boundary. So if I rotate this around, you can see that it's identified a patch inside of here. And if I zoom in really close and kind of rotate this over a little bit, we can actually see that that's a second layer of triangles. So if I was in inspect and I did a surface profile, I may get an anomalous reading in here where I've got some triangles that are below the surface, or they're really small and I can't see them because my model is really big. Well, in this case, this is command where we're analyzing for the boundaries. It will go through and show you if you have anything in there. And so with this, one of the things that we can always do is we have the same ability to select inside let's say the command select island. So if I go into element selection mode and I right click and say select triangles, in Modeler Lite, you have a lot more commands inside of here. Well, in this case, I can say select the island, so everything that's connected is selected. And in this case, there's my missing or like triangles that were floating. I can invert my selection and say delete. And then once we've deleted everything, now the model is completely cleaned up. So another tool that's a really good advantage that you can use where we may have stray data inside of here within the Inspector Lite, this command can help you out with that. Now, one of the other things that goes along with this is, let's say that you are, you have a part here and you guys may have 3D printers on site, and you've gotten something that's been scanned and it needs to go to a 3D printer. Well, we give you an analysis tool that is to check for water tightness. And with 3D printers, you have to have a completely watertight model. Well, we can actually go through and analyze the model to make sure that everything's watertight. And then that would give you something that you can now basically right-click and export this out as a polygonal model and straight into your 3D printing software, and you can go ahead and start printing. Another advantage to this is, let's say you're doing an inspection, and since this is an injected part here, we can see that it's thin material, and one of the things is maybe what I would like to do is a volume calculation on this. Well, in Inspector Premium, we have tools that can go through and do that volume calculation. However, inside of Modeler Lite, it's a one-click solution. Since I have a watertight model, maybe I would like to know how much plastic I'm going to need to inject inside of here. We can simply go through and run the measure volume command, and this will tell me exactly what the volume is of the part. So not only are we using Inspector Lite to go through, Modeler Lite to go through and improve the model, we actually have a measurement tool inside of here. Not only do we have one measurement tool, but we have a second one inside of here that will allow us to go through and measure the area. So let's say that on this part, I want to put a coating on a region through here, and I want to calculate the area of that region to see exactly how much coating I may need to calculate for that with my sprayers. I could simply come through and select that region and click my area button, and I have the ability to go through and quickly find the area of a part of the model. So again, another great tool that's inside of here, that's a measurement tool that could be used for quickly going through and assessing a model. The last thing I wanted to go over today is the command of reducing the number of triangles on the model. Now, if I take this model and I turn it into the display so that we can see the wireframe of the triangles, you can see that there's a lot of triangles on this model. And if we were to go to the properties and look, we have 843,000 triangles for this particular model. Now, what I would like to do is reduce the number of triangles on here. Well, we have that command that will allow us to go through and do a reduction. And one of the really strong and powerful algorithms and tools inside of here is reducing within a specific tolerance. So what I would like to do is reduce the number of triangles that I have here, but I don't want the model to deviate more than this amount. So in this case, this would be 50 microns from its original position. A lot of digitizers out in the market are within 30 to 50 microns as far as their standard deviation goes. So this is a good value that you can start off with. However, if you want, you could also reduce this. So maybe what I would like to do is take this and reduce the model, the number of triangles in the model, but don't deviate more than, say, 10 microns. Well, simply launching the command, we can go through and you can see that immediately there's not as many triangles as we had before. Now, how many did we reduce it down to? Well, we went from 800 and I think it was 34, let's say 800,000 down to almost 200,000. That's close to 70% or maybe close to 80% of a reduction with a simple click. And the model has not changed more than 10 microns from its original. So this is a very, very powerful tool, and this is really good for people that have CT scanners where your polygonal meshes are in the hundreds of millions, if not close to a billion points or triangles that are there. We can reduce the size down within Modeler Lite and get you working a lot faster within your inspection process. Now, in the end, when we've gone through and made all these improvements, don't forget that we can always send this back to Inspector by simply coming back through and using the transfer to PolyWorks Inspector. And it will seamlessly take this model and import it back into the Inspector module itself. Now, with that, I hope that you guys have seen the advantages that Modeler Lite can give you. And it's not so much that it's a full reverse engineering package. It's more something that can help you change your models around aesthetically for reports, fill some holes in if needed, and reduce the overall burden that you would have on the computer by reducing the amount of triangles on the model. And I really hope you guys would give this a try and see if this will work for you. With that, I want to turn this over to Carol to see what kind of questions we have.
Thank you, Todd. So the first questions that we have here. So we have a client that's having the full PolyWorks license. So what happens then if you transfer to Modeler?
Okay, if you have a full license of Modeler, you will when we use the transfer. So let me go back to Inspector. So if you simply just right click and say transfer to PolyWorks Modeler, since you have a full license, it will always open the full license. It will not directly import into Modeler Lite. So for those who have the full Modeler package, it's just a straight seamless shot in, and it doesn't go into Modeler Lite.
Perfect, thank you. So second question regarding the calculations for volume and area. So in the interface, when you have the results, there's no units shown. So could you talk about this a little bit?
Yes, sure can. So when we're dealing with volume, this is one of the things that always pops in class. And Carol's always really good about giving these questions that she likes to get me with these sometimes when I go a little bit quick. When we calculated the volume, you don't see units here. And typically with one of the things I always point out to everybody within a training class is the working volume, or excuse me, the working units, even though that disappeared, is actually down here in the lower right-hand corner. So you can see that we're in millimeters. However, when I launch the command, you'll see that this window pops up, and since the attention is on the window, the estimating volume calculation is running down here, it still is in those units. And that's the same for the area as well. Perfect. And thank you, Carol, for reminding me to point that out.
You have to thank the users. They're paying attention.
Oh, exactly. I don't think I could pull anything over on them. So.
And we have one last question, again, regarding this area and volume. Do you have like a workaround where we could report that in Inspector, those values?
Yes, those values could be used in a custom measurement inside of Inspector. So we could go through and fill that in. There's the possibility that we might be able to write a macro to do that as well.
Perfect. Thank you, Todd. And this is all the time that we have for the questions. This webinar has been recorded. It will be available on the Innovametric software website. Now, a heads up, people, we are restructuring the website. The webinars are now found under the About Us section. So navigate to the About Us section and you'll find the webinars over there. They will also be available on the Innovametric software channel on YouTube. Our next webinar is scheduled for November 14th, and we will talk about how to inspect parts without using a CAD model. So thank you for joining us this morning, and we'll see you next time. Bye-bye, everybody.